In this video, we are going to be discussing problem 6.17, or if you're using the older textbook, 7.17. So first of all, it seems like a super straightforward question, but there's a lot more to it than what it appears to be on the surface. And, you know, uh, it took me a minute to figure out the math of this question. So first of all, we need to calculate the pH of this particular molar solution of HCl. So what you would assume is pH equals to negative log concentration of hydrogen ions, so negative log 10 to the power minus 8. So you would have gotten the answer as 8. However, this is an acid. An acid cannot have concentration of 8 because that would mean it's a base. So an acid itself that just does not make sense. Because of that, there is a lot more math that is involved in this question than we first thought. So let's again read the question. So calculate the pH of so and so solution. And because we got a negative value, or we got a value of about 7, to the pH, we need to, it seems like we're missing something, right? So first of all, we've been given the concentration of HCl equals to 1.0 into 10 to the power minus 8 molar. Okay, now we need to figure out the pH. Okay, so the thing is, we need to consider both the sources of the hydrogen ions because it is so dilute. This particular thing, there is 8 zeros before this one, and like a decimal point, that it's so dilute. So we have to consider both the sources of the hydrogen ions. The first one is obviously going to be the water. So H2O plus H2O gives rise to H3O plus OH minus. Okay, that is source number 1. Source number 2 is HCl plus H2O gives rise to H3O plus Cl minus. Okay, in the case of this equation, first of all, we know Kw for this equation equals to um, 10 to the power minus 14 because it's water, right? And we also know water gives us equal number of hydrogen and OH minus ions. So we are going to be considering that to be equal to X. Okay, so we're considering the hydrogen and OH minus ions equal to X. Now, in this case, you have HCl plus H2O gives rise to H3O plus. So over here, the concentration of H3O plus from just the HCl will be equal to 1.0 into 10 to the power minus 8. Okay, so the cumulative, the total amount of, so, oh, sorry. Um, I just learned that trick, by the way. So the total amount of H3O plus would be equal to H3O plus equals to 10 to the power minus 8 plus X. So we're considering both the sources. And concentration of OH minus ion is going to be equal to X. Okay. Now, what we'll do is we will basically figure out Kw, right? Kw equals to concentration of H3O plus into concentration of OH minus. So what we will get, we'll get 10 to the power minus 8 plus X into X. Okay, equals to 10 to the power minus 14. So I think you've already figured out we will get a quadratic equation. So you get 10 to the power minus 8x plus x square equal to 10 to the power minus 14. So we're going to have to solve this quadratic equation. So let's first get it to the form where we are more familiar with. Okay, so let's switch this 10 to the power minus 14 to this side. So you'll be getting x square plus 10 to the power minus 8x minus 10 to the power minus 14 equals to 0. Okay, so first of all, you know x equal to minus b plus or minus root over b square minus 4ac divided by 2a. Okay, so this is the formula we use to calculate the like the value of x from a quadratic equation. For our equation, we have value of a equals to 1, value of b equals to 10 to the power minus 8, and value of c equals to minus 10 to the power minus 14. Okay, so I know it's a lot of simplification. If you want, you can skip ahead or pause right here and try to solve it on your own. But basically, I will be doing each and every step or solving each and every step just so that you can follow along. And this is how I thought I figured out the answer. But if you have a better way of doing it, you can do that too. So let's start substituting 10 to the power minus 8 plus minus root over b square 10 to the power minus 8 square minus 4a, which is 1, into minus 10 to the power minus 14. Okay, now this whole divided by 2 into 1. Okay, so that is the first step. Then you have minus 10 to the power minus 8 plus minus root over 10 to the power minus 8 square will give us 10 to the power minus 16. 10 to the power minus 16. Minus into minus is plus, so just gonna say plus 4 into 10 to the power minus 14. Okay, so this whole divided by 2. Okay, so this is further simplified as, so first of all, you have 10 to the power minus 8 outside, right? So root of 10 to the power minus 16 is going to be equal to 10 to the power minus 8. So what we will do is we will simplify this to get to 10 to the power minus 16 and then go from there. Okay, so you'll get 10 to the power minus 8 plus minus root over 10 to the power minus 16 plus 400, because you are increasing it to 10 to the power minus 16. Okay, so essentially what we're trying to do is we're trying to have these two as the common. So then we can just add 400 with this one. Okay, so I hope you remember this from your first chapter. So divided by 2. So basically you'll have 10 to the power minus 16. We'll take out in common 1 plus 400. Okay, so you'll get 401 into 10 to the power minus 16. Okay, so let's just write that. So 10 to the minus 10 to the power minus 8 plus minus root over 401 into 10 to the power minus 16. Okay, so this whole divided by 2. Okay, now again, if you want, you can like, I personally prefer giving you each and every step of the process, so which is why this will always be there. So this is equal to minus 10 to the power minus 8 plus minus. So 401 root over 401 is 20.024 into 10 to the power minus 8. Root of 10 to the power minus 16 is 10 to the power minus 8. Okay, so this whole divided by 2. Now we can either consider it to have a positive or a negative sign. We're going to consider only the positive sign, because if you have a negative sign, you're just going to be left with a negative value for concentration, and that's not really possible. So we're only going to be considering the positive sign. So x will be equal to minus 10 to the power minus 8 plus 20.024 divided by, into 10 to the power minus 8. I guess we should probably put brackets, into 2. So first we will be adding 20.024, subtracting, and then you get 19.024 into 10 to the power minus 8 whole divided by 2. And this is equal to 9.512 into 10 to the power minus 8. Now this is the concentration of the OH minus ion, because over here if you notice we considered the concentration of the OH minus to be equal to X, and we've gotten the concentration of OH minus which is equal to 9.52. Okay, so this is the OH minus ion's concentration. Now concentration of H3O plus equals to 10 to the power minus 8 plus 19 point, oh sorry, uh, plus 9.512 into 10 to the power minus 8. So essentially you're going to get 10.512 into 10 to the power minus 8. pH equals to negative log concentration of H3O plus, right? So negative log 10.512 into 10 to the power minus 8. Now this you will be simplifying it like we did the previous problem. So negative log A, log A into log B is equal to log A plus B, right? So let's just write it this way. Negative log, I should have put the bracket first, 10.512 plus log 10 to the power minus 8. So this is equal to minus 10 log 10.512 is 1.021 by this log 10 to the power minus 8 is minus 8. Now when you simplify this you get 6.979. Now I know this is a really simple step and you can easily just get to pH, but however if it was a more complicated problem, what you can also do is figure out the pOH of pOH using the formula pOH equals to minus log concentration of OH minus ions, and then we know that pH plus pOH equals to 14. Okay, so using this formula you can actually get to the same value, and when you do it this way, you get the value of pH to be 6.978, which is super close to 6.979. Honestly, if you round it, you would get 6.98 in both the cases. With that, we're done with this question. Also, yeah, I know it seems like a very simple question to solve. The reason we had to do all of this is because of the fact that when you calculate the pH of this, it's going to come up to 8, and it's an acidic solution. It cannot have a pH of 8. So we had to consider both the sources of the hydrogen ions, which is the water itself and the hydrochloric acid. If it had been a stronger acid, then you would have just as easily figured out, like you could have easily just used the hydrogen ion concentration of just the from the hydrochloric acid because it's so much more strong. But because it's dilute, we had to use the both the sources. We first of all calculated the we got this we first of all figured out the total amount of H3O plus from both the sources and the concentration of OH minus. We use the value of Kw to get to a quadratic equation. We then simplify the quadratic equation, and then we're able to calculate the value of X. That's how we were able to calculate the value of X, which is the concentration of OH minus ions. So from there, we were able to calculate the H3O plus and the pH. Also, you could easily just do it this way, where you calculate the pOH and then you get pH plus pOH equals to 14. And definitely try it out and see if you get the same answer. And with that, we're done with this question. In the next video, we will be discussing the ionization of weak acids.